All right, welcome. Today, we're going to do something pretty cool. We're going to totally change the way you see the world around you. We'll dive into the basics of chemistry, and while we're at it, we'll pick up some really important academic English. Think of this less like a formal lesson and more like an immersion into a whole new way of thinking. So, let's get started.
So you might be asking, why start with chemistry? Well, it's often called the central science for a really good reason. It's not some isolated subject off in a corner. Nope. It's the glue, the bridge that connects pretty much everything, from physics to biology, medicine to building new materials. It's like the invisible framework holding up all these other fields of study. Okay, so what is chemistry really? When you boil it all down, it's the study of matter. And in science, matter is just a word for, well, all the stuff in the universe. Anything that has mass and takes up space. So chemistry is all about figuring out what that stuff is made of, what it's like, and all the amazing ways it can change and transform.
And here's the thing. This isn't just happening in a lab somewhere. It's happening everywhere, all the time. That coffee you made this morning? Chemistry. The battery keeping your phone alive? You guessed it, chemistry. Even the soap you wash your hands with, it's all chemistry in action. It's the science that helps us decode the world we live in every single day.
You know, starting to learn chemistry can feel a bit like visiting a brand new country. It can be a little unfamiliar, right? So it's super helpful to have a map to get a sense of where you're going. That's what we're doing here today. Think of this as your guided tour, pointing out all the important landmarks of scientific thinking. All right, first stop on our tour, we need to understand how scientists actually figure things out. What's the process? Let's take a look at the rules of the game they use to explore the world.
It almost always starts with just curiosity. You see something happen, like water boiling on a stove or a piece of metal getting rusty, and you just wonder, why does that happen? So the big question is, how do scientists get from that simple why to a really deep, solid understanding of what's going on?
The answer is something called the scientific method. But take a look at this. It's not just a straight path from A to B. It's really a cycle, a loop. You start by observing something, and that gives you an idea, a hypothesis. Then you run experiments to test that idea. And the results of those tests, they feed right back into refining your idea. It's this constant process of asking, testing, and making your ideas better and better.
Okay, now this is super important, especially for building up your academic English. In everyday chat, we might throw around words like theory or law pretty casually. But in science, oh no, these words have very, very specific meanings. So let's get crystal clear on 3 of the big ones.
So you can kind of see the progression here. It all begins with a hypothesis. That's your starting guess. If that guess holds up after tons and tons of testing and gets backed by a mountain of evidence, it can grow into a theory. Now, a scientific law, that's a different beast altogether. A law doesn't try to explain why something happens, it just describes what happens over and over again without fail. All right, let's zoom in on hypothesis. A hypothesis is a tentative explanation. That word tentative is key. It just means it's provisional, it's a starting point. In other words, it's your best educated guess that you can actually test. Something like, my car won't start. I'm going to hypothesize that the battery is dead. See, it's testable. Okay, next up, theory. Now be careful here. In everyday English, we might say, oh, I have a theory, and it just means we have a hunch or a guess. In science, it's pretty much the exact opposite. A scientific theory is a huge deal. It's a really solid, comprehensive explanation that has been tested again and again and again by tons of scientists. It's our strongest explanation for why things work the way they do.
And finally, the scientific law. A law simply describes what we see happen. It takes the results from thousands of experiments and boils them down into a short statement. A lot of times it's a math equation. It tells you what will happen, but not why. Here's the classic example. The law of gravity tells you that an apple will fall from a tree. The theory of relativity, on the other hand, tries to explain why it falls. See the difference? One describes, the other explains.
Okay, so now we've got the rules of the game, the scientific method. The next thing we need to understand is how a chemist actually sees the world. It's really cool. They kind of have these 3 different ways of looking at things, almost like they're wearing 3 different pairs of glasses at the same time. This picture shows it perfectly. On one level, we see the glacier, right? The big physical thing we can see and touch. But a chemist is also picturing the invisible world, all the little water molecules that make up that glacier. And then they use a special language, a symbolic world, to write it all down and communicate it. So let's break that down a bit more. First, you have the macroscopic domain. Macro just means big.
It's the world of things we can see and touch, like a big block of ice or a glass of water. Then there's the microscopic domain. This is where the real magic happens, at the level of atoms and molecules. We can't see it with our eyes, but we can imagine all those tiny H2O molecules locked together in the ice or zipping around as steam. And finally, the symbolic domain. This is the special shorthand chemists use, like writing H2O to represent a water molecule. It's their language.
And really, this is the most important part. A chemist is basically a translator. They see something happen in the big, macroscopic world, like wood burning in a campfire. Then, in their mind, they translate that into what's happening at the microscopic level, imagining all the atoms and molecules rearranging. And finally, they use the symbolic language of chemistry to write it all down. That constant back and forth, that translation between these three worlds, that is the heart of chemistry.
All right, as we wrap things up, I want to give you a little toolkit to take with you. We've used some key academic English words today, so let's put them all in one place to help you remember them and use them like a pro.
Let's lock in this vocabulary. Remember, matter is just the physical substance or material that makes up everything. Mass is the amount of material in something. The space it takes up is its volume. And remember that word tentative? It means something is provisional or preliminary, like a hypothesis that's still waiting to be tested. Seriously, try reading these sentences out loud. It's a fantastic way to make these words stick.
So, there you have it. We've covered some of the absolute foundations of chemistry and worked on some important academic English along the way. I'll leave you with this final thought. Now that you know how to see the world like a chemist, through those three lenses, the macroscopic, the microscopic, and the symbolic, what are you going to look at differently today? What will you see that you didn't see before?